Good afternoon. Welcome to another session of Climate Careers Club after school.
Sure. I'm Juliane Borchert. I'm an experimental physicist at the University of Cambridge. I've just finished my PhD at the University of Oxford. I'm already also working on the same topic. And I specialize on new materials for solar cells. So behind me, so behind me you can see some solar panels. So that's kind of what the current state-of-the-art solar panels look like. So they're made from silicon. They work really well. They've actually gotten quite cheap in the last 5 years. But I work on new materials, which could kind of become the next generation of solar cells, which would be even better, a bit cheaper, and also potentially useful in more different places. So the current ones typically tend to be these big, stiff sheets on glass. And the stuff I work on could potentially be flexible. So you could make it on like a roll and then just take it somewhere and then roll it out, and the installation would be much easier than with the big panels that you have to like screw to special mounts and things like that. So it's kind of a new generation of solar cells, and I'm on the relatively fundamental side of things. So I study how materials interact with sunlight. So it's kind of an interesting thing. If you look at a material around you and you shine light on it, it's always going to interact with it. If it's, let's say, a glass pane, it's going to just transmit it. If it's a solar cell, it hopefully will absorb it and actually use the energy from the sunlight, and you can make electricity with that. So I look at a special class of materials called perovskites that are quite good for this. And yeah, I kind of go to the lab and test them and make little tiny test solar cells to see if they work well in solar cells. So that's kind of broadly what I do.
Thank you. At this stage, could you maybe share something that, from your perspective, working in this field, are there any misconceptions about this technology in the public that possibly are a frustration to you?
Yes. So when I tell people that I work on solar cells, oftentimes I get the answer, the response of like, oh, great, you're going to save us, which is very flattering and nice to hear. But it's also a bit frustrating because it kind of shows me this idea that people have that, oh, we'll just have to wait for some technology to save us from climate change. And especially when I say that I work on new solar cells. And I'm always like, well, the current ones are pretty good already. Please just go and use them. So I think kind of this, we'll wait for some technology to solve the problem, is fairly common, both in relation to renewable energies, but also to kind of capturing carbon from the atmosphere and storing it and things like that. And I'm like, that's all nice and good, but it's not ready. And please just use what we have right now, because renewable energies have gotten really, really good in the last like 10 years. And well, some of them, wind has always been quite good, but solar panels have gotten really good recently, and just use them. Like, yes, I'll develop the next generation that we can use in 10 years, but please don't wait for that. So please start doing things now. So yeah, it's always, I love technology, but it's not going to save us if we don't use it. So yeah, that's always a bit of a frustration.
Brilliant insight, if a frustration for you. Can we take a step back? So what kind of decisions were you taking when you were maybe Isabel's age that helped to shape where you are and what you do now?
Yeah, so I'm originally from Germany. So I went to school in Germany. So the school system is a bit different, but doesn't matter in the end. So I had to kind of decide on kind of, it's not as specialized as A-levels are. You still do a broad range of subjects, but I had to kind of decide on some focus subjects. So I did maths and English as my focus subject. So English was a foreign language for me, my first foreign language, and the maths, and I still continued with like physics and chemistry and biology and all that. And then the bigger decision for me was kind of moving to university, like what do I want to study? And I was really interested in the sciences in general, and I looked at all of them and ended up settling on physics because, in my opinion at the time, it was the most fundamental one that kind of explains the atoms and how like the tiny little things keep together, and kind of then chemistry and biology are using that to some degree, which I think I now see a bit differently. But then back then that was my idea of like physics is kind of the most fundamental one, and I really wanted to know how the world works. So I started studying physics, and the course was quite theoretical. We didn't do much experimental work. had a lot of maths, a lot of formulas and very theoretical work, which was good, but also got a bit frustrating for me at some point because it just didn't suit me super well. So I considered changing subject and looked around a bit, and then took this summer course, which was offered by a charity that was doing basically technology and like craft training for women specifically. So they trained women in like electrical installations and things like that. And they had a special course on solar installations. So I actually learned how to install these solar panels on roofs and how to wire them up correctly and all that. So the very practical side of solar cells. And it was a 6-week course over the summer. I really enjoyed it. But then I was like, okay, that's nice, but I don't think I want to do that all my life. Like installing solar panels, it's great, someone needs to do it, but it wasn't quite the right fit for me. So I was like, okay, I think I'll go back to doing it a bit more theoretical, a bit more on the science level. So it kind of gave me new motivation to go back to my physics degree and have an idea of what I'm going to do with this. Because at this point, the whole idea of understanding what keeps the world together was still interesting, but wasn't enough motivation anymore. I really wanted kind of to see what it was good for. So kind of doing research and looking into particular aspects of physics that are going to be useful for something in the end. So in this case, solar cells has been a really good motivation for me since then.
And if I understand correctly, it was really as a university student that became aware or involved with larger discussions around issues of social justice that you'd felt about before, and perhaps this married the two together. Your interest in how matter works with a kind of social purpose.
Mm-hmm. Yeah. So for me in school, I was maybe more so than most school kids would be now, relatively sheltered from kind of what was going on in kind of the wider world and politics. And I was very interested in kind of making the world a better place and kind of justice and things like that, but it was fairly vague, like it wasn't particularly focused. And then at university, I joined a group that was doing a lot of things around sustainability, both on campus and related to kind of politics in Germany. And yeah, so I learned a lot from that group about the kind of societal interconnections of the science I was doing. So kind of big discussions in Germany at the time about renewable energy feed-in tariffs and how they would change and so on. And then the kind of the wider context for then my work now. Yeah, so I think it really started at university for me to kind of look a bit more specifically at kind of green topics and questions about the climate, but also pollution more generally. So we have like, there was a discussion about a local coal plant because of the climate, but also because of the other pollution that that affects the like local area more. Yeah, so for me it was kind of university and then student-led groups at university that kind of gave me direction for this.
Just touching on that theme of the kind of the local environment, and also kind of someone who has moved to study and work in different places and has recently moved again. How do you connect on a daily basis with the living world?
I really enjoy kind of outdoor cycling and walking and things like that. And like, for example, because I moved to Cambridge in the middle of lockdown, I couldn't really do much in the sense of like sightseeing and so on to get to know cities. So I cycled around, visited all the local parks and nature reserves and things like that, which I really enjoy. And I think to the annoyance of one of my sisters who really finds it frustrating when I do that, I also, the scientist comes through when I'm in nature. I tend to take pictures of like bugs and plants and so on, and then use an online app to work out what their names are and stuff like that, which frustrates my sister to no end. She's always like, can we just keep walking? And I'm like, no, there's an interesting bug. Yeah, so I kind of, sometimes I even have a little pocket microscope that I carry around to like take an even closer look at things and stuff like that. So yeah, I think it's really, having grown up in a city as well, I think it's often underappreciated how much just the wildflowers and random bugs and so on are around, even in a city environment, in parks, but also just sidewalks and so on. So kind of, I try to keep my eyes sharp for that and to look out for that.
And drawing on all of this experience, thinking of the young people who will be watching this and are watching it now, do you have any tips or hints, both in terms of how they could connect with the natural world in their daily lives, but also if they're interested in issues of environmental justice, sustainability, what kind of things can they be doing now or in a few years' time, kind of enrich that?
Yeah, what I struggle with a lot at the moment is that a lot of the news is very, like, about climate change topics is very on the global scale of like, oh, the west coast of the US is burning, the Amazon rainforest is burning, the glaciers are melting. And it seems threatening, but also far away. And it's like, well, what can I do about wildfires in California? Very little. So it's kind of leaves me a bit helpless to see all these big issues that are seen far away. So for actually trying to do something, I try to kind of think more locally, and I think that's quite helpful to actually look around locally. Okay, where do I have some influence and control? Like my sport club, my school, my local council, where could I write a letter or ask someone, do you have solar panels on your roofs? Why not? Where do you get your electricity from? So just to start on the small level, but because like getting like a local, I don't know, fitness studio or someone to change their electricity contract to a supplier that supplies renewable energies, yes, might take some talking to them and convincing them, but it's not a like big insurmountable problem like wildfires in California. So I think to kind of really stay up to date with what's happening globally, but to think locally, like, okay, let's say the City Council of Oxford, for example, they have committed to doing something about climate change. They have declared a climate emergency, and now the question is, what does that mean? What are they actually doing? Do all the buildings that they own, like the libraries and the city hall and social housing and buildings that the city actually owns, are they well insulated? Do they have renewables incorporated and things like that? So kind of really concrete questions that you can just write a letter to your local councillor and ask them, and they might not know because they might not have thought about it, but then it's a good reason for them to start thinking about it. And yeah, so kind of try to do something on the local level where there's actually a chance of making a difference.
Thank you. I think that's a really valuable thing to hear. Coming back to your current work and what you're doing now, what skills do you enjoy using on a daily basis, and what is most satisfying about your job on a day-to-day basis?
So I really like doing lab work when it works. It often doesn't work, and then it's frustrating. But yeah, I really enjoy the kind of being in a lab and doing an experiment that nobody has done before, or at least nobody has done successfully before and published about. But to do something that is really new, and for a while until you like have really worked it out and then published it, for a while I'm the only person in the world who knows this detail. And it's often very small things, but it is quite fascinating to think that, oh, I'm the only person who currently understands how this material does this. And yeah, I find that really cool. And actually, let's see if I can manage this. I brought a picture. There we go. So one thing I do a lot is make little test solar cells. So that's an example of that. So they're little squares of glass with a stack of different layers on top, which then form the solar cell. And they're really small compared to the big solar panels, but they help me test out different materials. So I don't have to make a big panel each time. I'm just testing the material and then see which one to take further. And the problem is, I mean, we're in England, so the sun is not exactly reliable. I mean, it's pretty good this week, but if I want to test if the solar cell works, I can't just wait to like hold it under the sun and see if there's electricity coming out. So we have a kind of fake sun in the lab, which we call a solar simulator. And that's quite cool to use because like, okay, we've got a big light bulb and case around it and stuff that is basically pretending to be the sun. And has the same kind of light, color, and spectrum as the sun would have. And then I can stick my little test solar cell under that and see if it produces electricity or not, and kind of compare it to other ones. So yeah, kind of testing mini solar cells is really satisfying because you're like, oh, I've made this thing and it's now actually giving me electricity when I put it under the big light bulb. So that's quite cool.
Fantastic. Thank you for sharing. I would like to ask now, do our guests have any questions they'd like to put to Juliane while she's here to answer them? I'll give it a bit of time to have a think and respond. You could put them on the group chat as well if you'd like to type something.
I've got a question. I'd like to follow up on the question I think Sam was going to ask about skills. So what are the sort of the skills, perhaps I'm interested in the thinking skills that you would advise young people to try and develop while they're sort of going through school?
Yeah, so I mean, I'm a physicist, so the school skills I use most is the maths and physics I did in school. That's the kind of obvious one. Like if you want to study physics, you need to do A-levels in maths and physics. But I think what's often underappreciated is how much is also about writing and communicating. So in the end, a scientific discovery is worth nothing if you can't like share it with the world and people can start using it for the next scientific study and so on. So one really important part of my work is to sit down and analyze my data using all the maths and physics I've learned, and then to write it up in a like useful way. So for me, that kind of takes two avenues. One is like communicating with other scientists. So that's scientific publications. They're often written with very specific terms to be like really accurate, and are often a bit hard to read for people outside of the field. And then the other thing is more kind of communication with the general public. So that's things like this, but also kind of publications in popular science magazines and things like that. So kind of to spread out the information and the knowledge kind of beyond the little bubble of solar cell researchers. I mean, we all talk to each other a lot at conferences and so on, but it's good to make sure we also really communicate to the general public, who in the end fund our research with taxpayer money and everything. So we have an obligation to do that, but it's also, I think, important for the science itself, because if it's in some box somewhere gathering dust, that's no help to anyone. We need to make sure everybody has access to the science, especially when it comes to renewable energies that hopefully will actually get used. So yeah.
Well, thank you very much, Juliane, for your wonderful insights and answers today. And thank you for giving your time. It was fantastic to hear some of what you do and kind of what inspires you about your job.
You're very welcome. Thanks for having me.